Hello, everybody. So tonight, going to finish up our coverage of JavaFX, which frankly, I almost removed from the class coverage anyway. Really, the deciding factor on why it wasn't removed is because of the side things that, for what we're going to look at tonight, this is JavaFX tables, but the only place I had those worked in to the lecture. So that's observables and factories. A very, very powerful thing about Java that those naming conventions allow us to do. It's we can do a little bit more when we know how we wrote code. We don't have to see each other's code, just that agreement that we all write our code the same way, and we know what other people's code looks like, and then we can do stuff with it. Obviously, for tonight's example, it's going to be all our own code, but the same thing would apply elsewhere. Why is that not making a beeping noise? Wait, hang on. Oh, that's muted. That's why. There we go. I'll unmute that. There we go. Sorry, Mark. I hope you haven't been there very long. I just realized that the main computer was muted, so it wasn't making any beeping noises when people showed up. So yeah, so tonight's the last night on JavaFX. We're going to look at using tables, and tables are a very dynamic thing, right? Not like a spreadsheet grid where we just have a bunch of boxes to write things in. A table where, I guess in a spreadsheet, right, we can highlight a bunch of numbers there in the boxes and turn it into a table where we have filters and organization things, change the order, that sort of stuff, a step further. And to do that in JavaFX, we'll look at a couple very important things for Java, observables and factories. I guess the best thing to do is just kind of jump in and look at it in the example. Introducing it here, if you proceed further, both of those would be something that, like in a 400 level computer science class, there's lots and lots of details. But in general, we're just going to look at the basic idea of them, get an idea of how to use them. And that's enough to apply them in our code usually. So we'll just do it through example tonight. Or if there's something to write on the board, I'll pause the screen share and write it on the board then instead of doing it a whole bunch earlier. And while NetBeans pulls up, we'll pull up an example on my Chromebook here from a previous semester. Fall 2019. Pretty sure it's there. There we go. And we can probably use that little GUI that we've been putting together and just throw a table in that. Or would that throw us off? Yeah, I'll just keep using this one and throw a table in that. That way, in our main content area, the only thing there is labels. We'll just ignore the other stuff. I'll comment out those button things from the other day so that we don't accidentally click those and delete the label. Delete the label and then replace this with a table. Actually, that's already on, it's already a copy of that on GitHub. That's no point of branching. I'll need to comment that out. This is a different version altogether, so we'll just get rid of the button clicks. And those button clicks are in the previous version. I guess it probably should be a different branch on GitHub that we'll put stuff on tonight, and get rid of that label. That was just look at that. And yeah, I almost removed JavaFX from the class. It's becoming out of date. It's still in use. Desktop apps are still in use some, but anymore. It's like VS Code. The Electron framework is a web application. And well, it's actually a web application so that advanced programmers could customize the exact IDE they wanted very, very easily. It was never intended for beginners to use Electron framework, and then Microsoft just grabbed it and put it in a Docker container so that it looks like a desktop app. It just runs on the desktop without a browser. But it is a web application, and that's what the world's moving towards a lot more. We make one sort of web application. Oh, okay. Request to go ahead and make a new project. So I will do that. Close that, and we'll make a new project. But the world's moving more and more towards that, but it's a transition phase. And transition phases are a little odd, especially if you're learning at that time, because you have to learn what's established, and it hasn't faded out yet. But we can see that it's disappearing. With now that Docker's been invented, we can make a web application and we can deliver it like a traditional website or multiple ways across the cloud as a cloud app or software as a service, or we can throw it in Docker and get a desktop application right out of it. And then we don't have to write one program and run it wherever we want. Or other things similar to Docker would make a container to put that on a mobile phone or whatever sort of device we want. So there's ways that we only have to do one thing, and that's oriented towards web-based application, the JSP stuff, like we've been looking at a lot. But the only place that I had observables and factories worked into the lesson plan the way I've taught it since 2018 is in JavaFX tables, and I couldn't think of another place to put it. So that was at least that was a good reason to keep it, because it's not gone yet, but in the next few years, it's going to be fade out more and more and more. So if we set up an Ant application, there's a lot less folders, easier to dig through from a human perspective, but we'd have to manually configure everything. We'd have to go download the libraries, set them up as the module path, and include them, tell the compiler where they're at, and keep them around for all our projects and all of that. If we go with a Maven project, a lot of it's automated, but we've seen a couple times that some of it's not automated and it kind of falls apart. And it takes a lot of digging around to find the correct version. I haven't really looked at Gradle. Y'all can click on that and give it a try. Gradle is the opposite of Maven. Maven has the centralized location, so you can think of it as a good summary for the build file. Maven, there is one file, might have 1,000 lines in it. But Gradle would be the opposite, where there's 1,000 files with one line each. One of those is going to be much, much better for the traditional spinning disk drive, hard disk drive, and the other one is going to be much, much better for an SSD drive. But that's the packaging, and what we do with Java inside of them is essentially the same, but Gradle is mostly automated like Maven is. I'm going to go with Maven one. And the first night we looked at FXML, where we have the drag and drop GUI and do the markup language. That's probably what you'll do with it, but I'm going to go ahead and go with the simple JavaFX Maven archetype. So the one I want, yes, that one. So select that one. Wait for it to download everything. That was about 3 seconds, so it might have changed since last week. that was plenty enough time to do a quick comparison and see that the current Maven repository is different than the one that we downloaded last week. I'll call this tables. Got the company name and all that. Oh, we're gonna go ahead and finish. Oops. Architect night phone. Oh yeah, it did have to go back to the central repository to get that. We just did one last week. I don't know why I couldn't find a local one. So here we have our application. They kind of started it off at the stage. I'm gonna clear out all the junk, the default stuff, and rename this the way I name things with a GUI. And I always use Hungarian notation. If it shows on the screen, which technically the stage doesn't show on the screen, the stage is what holds all the stuff that shows on the screen. You think of the stage as the screen itself, but we see it. So I usually go with Hungarian notation there as well. Extends application. Excuse me. And I'll remove all that extras. Try to get all this extra stuff out of here. So it's just kind of like clutter. With all this, if we just show the stage runs, there's no errors, but we don't see anything yet. We haven't put anything on that stage. The one thing we do have to have is going to be a scene. And we'll want to put something in that scene. I just work upward and see how much we can fit in there. Because if we create a scene, SDN main is a new scene. And here we do hit a bit of a problem. The scene needs 3 parameters. One is what containers are we putting in there? What JavaFX controls? If we only had one label, it would be the label. But we have to put something on the scene. So there's nothing visible with the scene yet. So working backwards, we quickly get to the point that we do have to create something. No suitable constructor found for no arguments. And you can see the different constructors that are there, and most all of them have parent, then at least a parent, and then other stuff, parent and paint, which is a color, parent and 2 numbers is what we'll probably use the most often. What container or element do we have, and then how big is it going to be? So if we create a couple things, I'll just make a pane. That's our most generic one. I don't think we saw that yet. That is a container with nothing special about it. That is the most, every single container we have, the H box, the V box, the border pane, the anchor pane, every other type of container would be a child of pane. So that's the most generalized one that we can actually instantiate. Oh, question in the chat room. We have class next Thursday. No, we do not have class next Thursday. We're all for Thanksgiving. But Thanksgiving, Thursday and Friday are the only days the school will be closed. It used to be like a 4-day weekend. We take off Tuesday and Wednesday as well, but the schedule shifted around, and those 2 days became that full week fall break in the middle of October. So we have class Monday to regular schedules, Monday, Tuesday, and Wednesday, and then Thursday and Friday, the school will be closed. So we'll have class Tuesday, but not Thursday. And that was a really good question, Dallas. That's probably on everybody's mind, right? At this point in the semester, everybody's getting a little tired. It's like, do we have some days off coming up soon? Days off and good food or something? It's an important thing when we're getting exhausted near the end of the semester. Well, actually, I can probably put that in there. P in main and 777 by 444. It's a couple good numbers that might work okay. I think now is enough we can actually see something. Oh, wait, no, I forgot a thing. We have to set the scene. So before we show our stage main, we have to set scene, and then that scene we just created. Typical thing for programming. We don't want to creating it's not enough. We have to actually say what to do with it. Now we should be able to see something. Why is there nothing to see yet? Maybe we'll need a label in there. Let's throw a label in here. See if that'll give us something visible. Window test equals new label. Hello world. And then in main dot get children dot add all that label. Okay, why is nothing showing here? Oh, I forgot an important thing. I erased the main. Our main doesn't do anything. That's why it didn't show when there was a label. Let me go back there so we can see that. Comment that out and comment that out. And in our main, we can call application.launch and then pass in the args because sometimes we will need those. The first example that always comes to my mind is usually at the top of the GUI we're looking at. We'll see the file name. That's very, very common. And we would have to pass that in as a command line argument when we start the program. So we would want to pass those into the application.launch. Now we should see something running. There we go. So there's a pane, nothing in it, an empty pane with the scene and just the most basic stuff. Pane can't be converted to parent. I am not getting that error message. Can you share your screen with me real quick? So I can see what you're looking at. If you scroll up, did the correct thing get imported? Oh, up at the top of so it looks like it did not find, it did not, so there should be a JavaFX. Let me pull it back up on my screen. JavaFX.scene.layout.pane. Try just typing it in. So, so like what you have there for stack pane, and just take out the stack. See if that finds it. On line 6. There it is. Yes, auto imports can be dangerous. Like sometimes Control-Shift-I is a little bit easier. Did that do an error again? What? Sometimes the auto. Oh yeah, yeah. That's why I never do the fully automatic ones, because I know enough about. I know too much about machines. I'm not going to trust them to make the decision. And I think you just shared the NetBeans window. Did it open? Okay. Yes. So definitely an important thing to watch out for. A good reminder. Little bitty differences like that. Clicking the wrong item, it'll just try to make a new. First thing it's going to try to do is make a new class in your project with that name instead of importing one. And actually, we don't even need that label. I'm going to get rid of that. Get rid of the import up here. Because what we want to look at now is a table so that we can get into these interesting things that I've been talking about, that naming convention since day one in this class. And we get there's a lot of power, extra power we get when we just all write our code the same way. We know what other people's code is going to look like. So, and with tables, we have to use one of those powerful things we get from that, something called an observable. And observables they track the data, they track changes. They can make changes, and when a change happens, they can let the rest of the program know about it. So if we decided, oh, that data class we have is suddenly not enough, we need that. And we have a name field and suddenly realize, oh, we should have done first name and last name. So instead of going back to the code, that gets changed on the fly. The observable can let the rest of the program know that, because, well, we know that first name, last name would be spelled with camel case. And then we would have get first name, set first name, get last name, set last name, and all that gets returned. The convention is, we call it Java beans, right? Private data fields, written in camel case, the default constructor, so the empty constructor that doesn't do anything, getters and setters for all the data fields, and preferably the toString and equal, and it doesn't hurt to implement the comparable and serializable interface, so we can do selection structures, but the interface ones are really optional, and even the cascade ones, toString, toHash, those are optional. We just really want the default getters and setters and all that. So the data we're going to work with. So let's go ahead and set up a data class to work with here. So I'm going to create a new Java class. And y'all have seen my generic classroom example enough times to probably already know what what our data class is going to look like here. That way we don't have to put a lot of thought into the data we're working about. It's the same one over and over and over again, and we can pay attention to the syntax and what we do with it and how we move it around. So, not people, we make person, I guess an array or list of them we would call people. Our whole table would be people. But a person class and then following the bean convention, we'll have a private data field. It's a string. We'll call it name. A private integer called age. And a private string called count. I had to think awful hard about that. It's been a long day. I've been here since like 8 o'clock this morning. I had to be here for high schoolers coming in for a field trip and a whole bunch of other VR stuff going on today. But today was the day that's been keeping me busy. Like all the different to-do lists I have all had big things due on the 17th. So I've been very anxious to get past today so I can try and catch up on sleep like later tonight and all the way until Sunday or something. Now we have that. We need the empty constructor. So in NetBeans, Alt Insert. If you're in Eclipse, right click, and on the context menu there's a source menu, and under source is the generating code. It's in different places in IDEs, but it's the sort of code that doesn't take any thought. It's always exactly the same. And computers are great at typing the things that don't take any thought to type. The computers are much, much better than us. So the ones we can generate code for, we want to. So we need to generate the empty constructor. And that's the only one we really need. So I'm just going to do that one right now, but I almost always do multiple constructors. If there's 3 data fields, there's not very many total possible permutations of those. There's 3 where we're doing one at a time. Then we have 1, 2, 3 combinations of 2 at a time, and there's only one way we can do them all 3 at a time. There's not very many ways. If there's 3 data fields, there's not very many permutations to get through every single one. 3 factorial is a really small number. Factorials grow quick, but 3 factorial is only 6. So it wouldn't take long to get all those constructors, even if we type them in. I'm just going to do the empty one. That's the bean convention. And then all of the getters and setters. And I'll go ahead and do the toString and use the string builder. Oops. Insert toString, and I'll click the use string builder to just get that generic. I'm not sure what to call that. I guess just a list of it. It almost looks like a dictionary, but that's not the way we would write a dictionary in Python. But a basic data class, I don't think we'll need that, but this is what we want to put in our table. And we have our data probably in a MySQL database, which is a server thing. And we looked at PHP My Interface, a common one to access that. It's a little overwhelming because it does every single thing that has a button for every single function available in MySQL, which is a lot of buttons. And it's probably gonna overwhelm most people. We just need a few filters and things. So we grab our data from the database, bring it into a class like this and throw it up on a nice simple table with basic filters for the managers to click through and be all impressed at what they can do, what they think they can do with a couple little filters on the data. But some sort of class to do that. And then that is what we will put into a JavaFX table. So first thing, the table itself is going to be a table view. I think I kind of went back and forth a couple times the other day with that first example, setting things up. My general trend is that if it shows on the screen, if the user can see it, I give it global access. So everything that's visible on the screen, I tend to give it global access. So like this pane, that can be seen. So really, I'm gonna take that out of there and move that up here as just a private data field for our app class. A private pane, P and main. I'm sorry. Glad you can make it. It's usually not as many people here. So we were looking at JavaFX tables. Yeah, I guess you haven't missed too much. We restarted a project and going slowly over a review it. One more review since it's the last night of JavaFX. Okay, so the general trend here is, or my logic for doing that is that the user can see it. That means they can get to it from anywhere. So they should probably be able to access it from anywhere in the code as well. And our table view will need a similar thing. I'll set it up as a private data field. It's a table view, and tables do require a generic type. It does have a generic. And in our case, it's going to be that person data we just created. The standard classroom example I use. What's a good name for this? Table people. I'll use the plural one on the table. I'm gonna go ahead and initialize this too. As a new table view. Well, Zoom thumbnails are in the way, as they often are. And check the imports and JavaFX scene control table view. So table view is kind of like the menu that we saw the other day. Things going in a certain order, right? A menu bar holds menus, and menus hold menu items. Well, tables, what do tables hold? There's two options. Data, but usually a lot of data, right? Yeah. And columns of data, or rows of data, whichever way we would want to set it up. I'm gonna set it up with, since our data class is set up like the columns, we'll throw in some columns. But we could also have our data class set up the other way so that it would make more sense to throw it in as rows. And we'll do a column for each one of those. Now
That's what's your screen.
Yes, it is hard to see text. I was doing that even before COVID, where when everybody would be in the class, you would still have to broadcast text across the internet. It's just impossible to read across the room. So we'll create this table view, and then we'll need to put into it a bunch of columns. And these are a little bit different to set up. So a table column. Columns would be dynamic, right? That's not gonna, the table view, I gave global scope, because we'll always see a table. But we have filters, so we can make the columns come and go. In our case, probably not, because our example is only gonna have 3 columns, but we'll have the little X so we could remove columns, or the little drop-down menus, so we can bring them back if we need to, stuff like that. So a table column, it actually needs 2 generics. One is the type of data that's going in there, the data class that's going in there. So something from our person class. And then what type of data is it? And it's, the first one is going to be string data. So we have to do both of those in the a doubled up generic. Give it some sort of name. I'll say CLM for column, and our first one is name. And that'll be a new table column. This side's a little more predictable. It's obvious what goes in there, or what goes in the angle brackets, so we don't need those. And then in the constructor, well, let me import that. In the constructor, which isn't on the TVs in the classrooms, get this out of the way. Well, I guess both of y'all are logged in here. We can put in a string in the constructor for the column header. So if you want a column header, you would put it here. So I'll write it all in uppercase, so that's the only thing in all caps here, so that it's obvious where that's coming from. It's not necessary, but I have found, I guess I should say, it's technically not necessary, but I have found that I'm going to go ahead and call it necessary to set a minimum width. Because it is one of those things, JavaFX is very dynamic and always goes for preferred stuff. So if you don't set a minimum width, you leave it to a mindless, non-intelligent machine to decide how wide your columns should be. And sometimes it might regularly decide that column only needs to be a couple pixels wide. It's like, oh, there's only 40 letters here. That can fit in 3 pixels. So set some sort of minimum width. And column name dot. I have lots of things. I'll go to setters. Set edit, set sort, min width and max width, which, like everything in JavaFX, this is the preferred width. We want it to be, I don't know, let's say 200 pixels wide. We have 3 columns, and in total it's 777 on the screen, so 200 seems a little reasonable for the minimum width. And then it'll actually stretch it out a little if we do all 3 of them 200. Actually, the other one, next one can probably be a lot shorter than that. Oh, and now we need to set up the stuff for this. So we need to use a factory. So column name set cell factory or value factory. We want value factory. And a factory is an alternative to a constructor. We did put a constructor in our thing, but when you think of a constructor, let's use an analogy of like craftsmanship on furniture. Chairs in the classroom. Some of y'all are in Zoom call, but you've seen enough classrooms to know that this one is full of really cheap chairs because the school had to buy hundreds of them at once to fill lots and lots of classrooms. And so they're not high-end custom-made chairs. The constructors, that's like the really high-end office chairs where some master carpenter sat down and spent a lot of care on that one piece of furniture in particular. Versus a factory, one of the factories in China or Taiwan, where the goal is just to shove out as many chairs as quickly as possible. They have a quality control person, and if the chairs don't meet quality control, they just go in the trash and nobody even cares. They spit out so many so quickly. We can do the same thing with Java objects. With our constructor, we're building that nice, carefully building the exact precise one we want, and we'll keep it around, carry it all the way through our software, and take care of it and hold on to it the whole time. But with a factory, we quickly spit out disposable objects. If we need to call a method, we spin up the factory, create an object, run that method the one time, and then throw it away. So we're just spitting out disposable objects with the factory. An alternative to a constructor, and depending on the needs, we can do it. So in a table where we're gonna have filters and I guess all the different things would fall under the category of filters. We're constantly going to be changing our data, which means we're constantly going to need to be changing this stuff back and forth. So we need to set a cell value factory. And this is the reason I left Java, made sure to leave Java. This was the deciding factor in keeping JavaFX in. Didn't mention factories anywhere else, because after this, we're getting into data structures, and then we'll be into just what the CPU is doing for a couple of weeks. 2 weeks. And then we'll get back to, then we'll do some interesting stuff at the end. And the way we want to create our factory is we're going to create a new property value factory. And I'm going to put empty angle brackets because I want Java to figure out what it needs to be each time. And then in parentheses, put the name of the property from our data class. So this is the string data called name in all lowercase. And if you want to name stuff differently, like you just really want to use Pascal case for everything, make sure this matches what you're doing over there. But in Java, it's normally camel case. So make sure this string matches the property name over here. And then that will create a factory that will spit out a factory that will spit out the data for the cell. And then dispose it. It spins it up very quickly, just a few clicks of the CPU clock, enough to get it onto the screen, and then disposes of that object. So very, very efficient on memory. Once it's on the screen, it gets rid of all the background part. And then when we need it again, it creates a new one. So that's the idea of a factory. The basic introduction of it is just to quickly spin it up, and instead of carefully making the perfect object for our software, we're going to make a whole bunch of disposable ones and single-use disposable things, and use them and throw them away. Depending on the situation, it's usually, as you gain more and more experience with software development, it becomes obvious which situations are better for a factory and which ones are better for an object. But you'll want to actually see it in applications in a few places. This is probably the only place we'll use it this semester. I guess we have a couple other columns we can use. So we have another column, and it's going to be almost identical. Still using that person data class we created, which just the generic classroom data I always use. That way we don't have any distractions there. We can focus on the Java part using the same data. And our second one's and over here, I use the primitive data type int, but for our generic, it does have to be an object. So over here, it is the integer with a capital I. And this is column age. It's a new table column. And give it, the constructor here gets a nice little label for it. Oops, come in parentheses, there we go. And they claim it's not required, but I have found that it kind of does. It strikes me as required that we need to set a minimum width on the columns because the computer is not good at deciding how much space it needs to show our data. The computer does not have eyes. It cannot accurately judge how wide those graphics need to be. And then we'll set a cell value factory. And make sure you're doing a cell value factory because a cell factory would be something entirely different than a column. I guess instead of rows and columns, we could also do an individual cell one at a time. But we're doing the whole column, so we just need the cell value factory. And our callback, notice the callback needs, in the predictive text there, needs to call the cell data features for person data with an integer, and it needs to be some sort of observable integer value. That means that it follows the beans. Other things can keep track of it. Anything that inherits from the observable class or implements the observe interface will notice any changes, even dynamic changes to a compiled script. We can do that with observables, dynamically change an already compiled script. We can do that with factories. It's not really an intro to Java topic, but a very, very powerful thing. We'll kind of subtly get there. And then it can let everything else in the entire software package know this stuff is changing. An observer will keep track of that. So we need an observable, something that can call back an observable feature, and a property value factory is the most generic one built into the language that inherits from the observable class, so it can observe anything that we follow those typical bean conventions on. The getters and setters and all that stuff in the class. And if we need to add another one, that property value factory will notice that and tell everything else in our software that it just saw a change and that it's happening. Introducing it, that probably sounds kind of confusing, right? We changed the text file. Well, it probably sounds very, very confusing to think about changing a already compiled version, but it introduction to Java. After you do more and more things and see it subtly already applied in the background, it'll start making more sense. And yeah, then work up to doing it in your own code, because it is kind of confusing to do in a text file. It's nice to have the ones already built for us from people that have been programming already have decades and decades and decades of programming experience. We can use the ones they built and then build up to making our own. I guess we need one more column. So it'll look exactly the same. We set up our data class and our other data was string. Give it a reference value, no surprises there. And it's a new table column. it's obvious what would go in the generic on this side, so we can omit that, or we can type it in if you just like to see it typed in there. And then here is a label for the table header. Town. Write that in all uppercase. I'm gonna go ahead and set a minimum width on town.set min width. I'll go back to 200, see what that looks like. And then set up our factories. So column town. We need a cell value factory. And to create that, we're going to set the callback to a new property value factory. And the property value factory needs to observe our town data field over in the thing. And if we say observe town, it looks like a string here, but it knows that's a data field. So it's also watching the getters and setters and other things that we haven't really seen in our class that would relate to that. The getters and setters are kind of the minimum. Purpose of inputs underneath those in a moment. Have that on the example. And so we have some add and delete buttons. Okay. So our previous example, that's all I had. Well, it's very, very different. So I had to sit there and think very hard about what I was doing. Was this 2019? This is a slightly different example, but some of the basic things there, I want to make sure everything's covered. So now we can put this on here. And it's we have to do it in two sections. So we have our table, the table people, and we have the columns to go in there, but there's two different parts to the columns, right? I'll just do the columns. I'll come back and do the other one. Let's do it one piece at a time. So our table, what did I call it? Table people. That was a good name for it. We want to get the list of columns. Oops. So go ahead and grab the list of columns that we already have. And then, like we've seen before, add all, and the table's going to hold columns. And then we can just list out the ones we want to add to it. So we're going to add in column name, column age, and column count. And then I will put that in the pane. I think I didn't delete that, did I? So pn main get children, and pane is the most generic container. Every single thing that we can put other JavaFX elements inside of is a child of pane, or somewhere down the line it inherits what's in pane. And add all, even though there's only one, I found it's better over the years. I found it's better just go ahead and put all, because then you don't have to change that when you come back and add more if you add more stuff later. And we're going to add table people. So we don't have any data for it yet. Kind of need to add some data or read from a file or something. But you see, we have our basic table there. If I click up here on the headers, it wants to put things in alphabetical order, even though there's nothing there to be put in alphabetical order. which, so that's looking good. We could probably use a way to add data to our table, right? So some input fields. So I'm gonna set up some text fields that match up with our columns. So I'll come up here, set a private text field. We haven't seen that yet. That's the standard input, but I'm pretty sure our textbook mentions those a lot. Why did I just call that text field? That's not a good name for it. TXT name is a new text field. I'll go ahead and initialize it here. Import that. A private text. I'm going to copy that because the other two are almost identical except for the reference value. Text age and text town. And those we need add and delete buttons maybe. Yeah. Private button btn add is a new button. And I'll just say add. Import that. Copy and paste that and do a button remove. Probably a lot more buttons we would actually want if not under classroom time constraints. But we want to at least be able to add stuff to our table and take things off of our table. Forget selection mode. Yeah. And to run this, thinking down here underneath the table would probably be a good spot for the buttons. That way it kind of lines up. Not going to line up. Like, not going to be perfect. We could make it that way eventually. It'd be a whole lot easier to make it line up perfectly with FXML, and we're dragging around our mouse and using anchor panes and things like that. But I'll stick the, actually it looks like there's way more room over here. 200, 100, 200. So it only uses the space we asked for. There's a whole bunch of space over here. So maybe the inputs would go better down the side. Lots of different options, right? Sometimes the best thing to do is go ahead and, especially for the GUIs, a visual thing, do the traditional artist thing. Make several versions so you can look at them side by side and see which one's best instead of trying to think it through in your head. Actually, like logos for marketing firms, they don't sit there and think about it and then draw the one logo they're going to use. Right? The artists draw hundreds and hundreds of logos, and then they look at all of them side by side and pick the one they want. So I'll put those in going down the side. They'll need to be vertical. So I'll put those in a V box. I'll just create that down here. V box, VBX inputs. It's a new V box. And we haven't really seen this one. So we always think on the earlier examples, we would do this and on the next line, get children that add all. We can put them in the constructor as well. So we have our text fields. So like TXT name, TXT age, TXT town, just because we haven't really seen that with that style yet. It's equivalent. The constructor is very overloaded. There's lots of versions of constructors. So that's the same as using the empty constructor and then doing the other stuff on the next line. Oh, actually, I guess at the bottom, we'll need a couple buttons. So I'll put text box, text box, text box. This is like an art thing, right? It's a good idea to sketch things out. So we have our table. That's where our table is. So I'm thinking input, 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 button, button. Something like that. So to get we'll have to put these in an H box to get them horizontal lined up like that. And all of that into a V box to get lined up that way. And then it needs to be horizontal to the table. So all of that goes into another H box. And then all of that sits in the pane on the window. So it doesn't hurt to sketch out the idea and think about what's going on. Just jot it down on paper really quick instead of trying to do it all in your head all at once. So the H box needs to go into that V box, so we need to create that first. So H box, HBX buttons is a new H box. And it's going to have our two buttons, BTN add and BTN remove. And then we'll have another H box, which would be HBX everything is a new H box. Oh, and remember to H box and V box have two capital letters. I've definitely made that typo more than anything else in Java. But two capital letters to start out those ones. And then this will have those previous things. So the table, people, and then the VBX inputs. What's missing here? Oh, yeah. Then those buttons go at the bottom of this V box. You see all the stacking there? We get the file names out of the way. We don't need file names right now. So lots and lots of stacking and organizing and layers of containers to end up with the direct positions we want. Somewhere wrong. What did I? Oh, and then HBX everything goes into the pane, and then the pane goes on the scene. And sorry, I moved the table into the H box and forgot to take it out of the main pane. Now hopefully we'll see them. There we go. So all that stuff, some inputs, and a couple buttons to add and remove data. Put data in our table, take it out, and then, well, from the little arrows, you can see there's automatically some stuff built in there. So because we're ready to actually add and to add and remove our data, but that might be a good time to take a break, right? I think they get quickly head nod showing up here in the classroom. Does 10 minutes sound good to everybody? All right, let's see. No, otherwise we'd have to stop in the middle of something, so it sounds like a good stopping. Seems like a good stopping point. 7:07, so we'll get back to it at 7:17. We'll create the add and remove functions, and then we'll probably create a method that just loads in a bunch of data automatically, so we don't have to keep adding it to the inputs. Let's see, stop the recording.